In this lesson, we're going to learn how to calculate a z-score and then interpret that z-score. So a z-score is a standardized value that measures the distance each value is from the mean in standard deviations. So it helps you to compare, like apples and oranges, two completely different data sets. It helps you decide if a value is really unusual. To calculate a z-score, what you do is you take the data item minus the mean and divide that value by the standard deviation. Okay, so that's the formula in words, but I just want to point out that you're going to see this formula expressed different ways. You'll see it as x minus the sample mean, which is x bar, over the standard deviation. Or you may see it another way, so let me point out some other symbols. So for the mean, we know that x bar is the symbol for the sample mean, but if we're talking about a population, we use this Greek letter called mu. It's just a letter in the Greek alphabet, mu. And for standard deviation, we know that we use s sub x for the sample mean, but if we're talking about a population, it's the Greek letter sigma. Okay, kind of looks like that O with a little loop on the end. So you might see the formula for a z-score like this, but sometimes you're going to see using a mu and a sigma depending on what type of values you're working with. So you might see x minus mu over sigma. So I think it's probably easiest just to recognize you take your data item, you want to find how far away from the mean it is by subtracting, and then divide that by the standard deviation. Here's a great example from Skew the Script to determine who is the greatest of all time? Who's the GOAT? So we've got Wilt Chamberlain, Michael Jordan, and LeBron James. And there's always this debate of who is the best basketball player. So let's specifically look at who is the best at scoring points per game. So what I have on the screen here is that in the decade that Wilt Chamberlain played, in the 60s, he was scoring on average 30.1 points per game. Jordan, 30.1, and LeBron, 27.1. So if we were just to look at their average, well, it looks like Wilt and Jordan are tied, and LeBron would be after them. But what makes it difficult to compare these players is that they played in different decades. Okay, so how do they compare to the skills of the players that they were playing with? So if we look at what was the mean of the other players in the NBA at that time, 10.8, 8.7, 8.4, how do they compare, related to the others? We also should look at the standard deviation. How close together are the other players? Notice the greatest spread was back in the 60s. So to see how they compared to these other players, we're going to calculate the z-score for each of our players. So for Wilt, I'm going to take his value. He scored 30.1, find how far from the mean he is by subtracting 10.8 and dividing this by 7. And when I do this on my calculator, I get a z-score of approximately 2.76. So I'm going to interpret this. What does this mean? This tells me that Wilt scored 2.76 standard deviations above the mean of 10.8, which is pretty unusual. We're going to start to see that anything above 2 standard deviations away from the mean is considered an unusual value. So let's see how Jordan compares. So Michael Jordan was scoring 30.1 points per game, subtract the mean for his decade, and divide it by the standard deviation. And I get a z-score of 3.63. So this is saying that Michael Jordan scored 3.63 standard deviations above the mean of 8.7. And now let's check out LeBron. So he was 27.1, his data value, minus the mean, divided by the standard deviation. And that gives me a z-score of 3.4. So again, he's scoring 3.4 standard deviations above the mean. So what's this showing us? All 3 players are definitely unusual compared to the other players at their time. How unusual? Well, we can see that Jordan is the most unusual. So we would say that Michael Jordan's the GOAT based on this analysis. Of course, there are certainly other ways to analyze a player. And it looks like LeBron's second, and Wilt would be third when we compare them to the players of their time. So now let's look at players who were not the best. So here we have Adam Morrison, and his points per game was only 2.2 for the year he played. And to be fair, this was in 2009, and Adam only played 44 minutes in total for the Lakers. At the time, the two best players on the Lakers would be Kobe Bryant, and he played a total of 2,960 minutes, and Pau Gasol played about 2,999 minutes. So he certainly didn't have much playing time. But if we were to calculate his Z-score, let's see how he compares. So he had just 2.2. The mean of the league at the time was 8.4, divided by the standard deviation of 5.5. This time I get a negative value, approximately negative 1.13. So what does this indicate? That negative is indicating direction. So Adam scored 1.13 standard deviations below the mean. We're just going to do a few more practice problems. On one test, your class achieved an average grade of 80 with a standard deviation of 8 points. If you got a 96, what is your Z-score, and interpret the Z-score? So to find your Z-score, you're going to take your value, subtract the mean, and divide by our standard deviation. This means that you are 2 standard deviations above the mean. Now your best friend got a 76. What's her Z-score? So you're going to do 76 minus 80 divided by 8, and that gives me negative 0.5. So my friend scored half a standard deviation below the mean. So compared to the others, doing worse than the average. What test grade has a Z-score of 1.5? I'm going to zoom in here to give us some more space. And I'm going to use the formula to kind of reason this out. So Z-score is your data value minus the mean divided by your standard deviation. I'm looking this time for the test score, which is my data value. So that's my unknown. So I'm going to use a little algebra. I'm just going to substitute what I'm given. So my Z-score is 1.5. Data value, I'm going to let that be my variable. The mean was 80, and the standard deviation was 8. And now I'm going to solve this algebraically. So to do that, a couple ways you can do this. I like to think of it like a proportion. If I put this over 1, then I know I just need to cross multiply. So on the one diagonal, I'd have x minus 80, because 1 times that is just x minus 80. And then 1.5 times 8 would be 12. Now all I need to do is add 80 to both sides, which gives me a test score of 92. So my friend scored a 92, or not my friend this time, just what test grade, so a 92. Lastly, Mrs. Stoltzfus calls home whenever a student earns a Z-score of negative 2.0 or worse. What grade will get you a phone call home? So this means if your score is very far below the mean, or how the rest of the class is doing, there's a concern. So what we're going to do is we are thinking backwards. We don't know our x value. So I'm going to use my formula. So this indicates that if you're very much below what the rest of the class is doing, there's a concern and your teacher's calling home. So I'm going to use my Z-score formula. So I'm going to do the x observed data value minus the mean divided by the standard deviation. And if this is less than negative 2, your teacher's going to call. So we don't know x, but we do know the mean. That was 80. And the standard deviation was 8. And I'm going to solve this inequality. So I need to get 8 out of the denominator. So I'm going to multiply both sides by 8 to get rid of this. So my 8's cancel, would give me x minus 80 is less than negative 16. And then I'm going to add 80 to both sides. And I get x is less than 64. So if you score lower than 64, Mrs. Stoltzfus will call home.